All right, let's tackle one of philosophy's oldest, most stubborn headaches. It's a puzzle you can write down in just 4 words, but believe me, it has been tying the world's smartest people in knots for centuries. We're talking about the liar paradox, and today we are going to unpack a brilliant new way to finally solve it. And there it is, the little troublemaker. This sentence is false. It looks so simple, right? But just try. Really try to figure out if it's true or false. Go on, give it a shot. You'll pretty quickly find yourself completely and utterly trapped. And this is the trap. See, if the sentence is true, then you have to believe what it says, which is that it's false. Whoops, that's a direct contradiction. Okay, so it must be false, right? Well, if it's false, then what it says is wrong. And if it's wrong about being false, well, then it has to be true. And boom, you're right back where you started. It's this perfect, maddening, inescapable loop. For literally thousands of years, the general consensus has been that this sentence is just broken. It's logical poison. It's been called undefined, pathological, a pure contradiction that just shatters the basic rules of truth. But what if the problem isn't the sentence at all? That's exactly what the source material for this explainer argues. The problem isn't the sentence, it's our rigid way of looking at it. For centuries, we've been trying to force this incredibly dynamic, self-referential idea into a tiny, static box that we've labeled truth. So this is the old way of thinking, what the source calls static semantics. It's a system that basically has only one slot available for a truth value. Every sentence has to fit neatly into either the true bucket or the false bucket, period. There's just no room for anything else. In this static system, the liar sentence creates a totally impossible equation. It demands that its truth value, let's call it V, has to be equal to not V at the exact same time. Just think about that for a second. Nothing can be itself and its opposite simultaneously. It's like asking for a number that's both odd and even. It just breaks the whole system. So how do we get out of this mess? Well, the proposed solution is kind of radical. We add a new dimension. What if truth isn't just a static, fixed state? What if it's a process that unfolds over time, or maybe more accurately, over steps of evaluation? And this brings us to dynamic valued semantics. In this new model, a sentence isn't just a statement. It's more like a little machine. It has 2 parts. Its current state, its value right now, and an update rule, which is basically a built-in instruction telling the system what to do next. And right here, this is the genius move. The old model, the static one, demanded the impossible, that a value at a single moment in time t had to be its own opposite. But the dynamic model makes this tiny but absolutely crucial change. It says the value at the next moment, at t+1, is the opposite of the value now, at t. And you know what? That's not a contradiction at all. That's just a simple, logical instruction for how to change over time. This is where we get that big aha moment. Because when you let the liar sentence run according to its own rules inside this new dynamic system, it doesn't break logic. Not at all. It follows a perfect, predictable pattern. It's not a logic bomb. It's a clock. Okay, let's walk through it together. Let's say we start by just assigning it the value true. Its internal rule kicks in and says, all right, at the next step, I'm false. Then, at that next step, the rule applies again. Okay, now I'm true. Then false. Then true. It never settles on a single answer, but, and this is the key, it never explodes either. It just enters this perfectly stable 2-step oscillation. Forever. As the source puts it, the liar becomes a deterministic oscillatory semantic process. Now, that is a very fancy way of saying it's just a predictable back-and-forth pattern of meaning. It's not broken logic, it's just doing exactly what it was designed to do once you put it in the right kind of system. So the takeaway here is actually huge. We've turned what we thought was a paradox into a functioning machine. And this isn't just some abstract philosophical game. This shift has really profound implications for how we think about truth, logic, and even the future of technology itself. So let's just quickly recap the diagnosis before we get to the really cool payoff part. If the sentence itself is actually a stable, predictable process, then why on earth did it look so broken for all this time? Where did this idea of a contradiction even come from in the first place? This right here illustrates the core problem beautifully. The source calls it an architectural mismatch. You see, the liar sentence is a dynamic object. Its command is basically, transform me, but for centuries we were forcing it into a static box that could only demand one thing. Give me one fixed value right now. The result wasn't a true logical contradiction, it was a system crash. The container was simply the wrong shape for the content. And this leads to a really powerful philosophical shift. We tend to think of truth as a fixed point, right? A final destination, one single correct answer. But this new model suggests that sometimes truth can be a process. It can be a stable pattern, a predictable rhythm. Truth doesn't have to be a point. It can be an orbit. And this is not just theory. This has some seriously mind-bending potential for technology. I mean, imagine computer memory, where a bit of information isn't just a static 0 or 1, but a stable oscillating process, a tiny logical clock holding information in its rhythm. Or think about AI and complex search algorithms. Instead of getting stuck in an infinite loop and crashing, an AI could recognize the pattern, classify it as a harmless oscillator, and just intelligently move on. This is a fundamental shift from brute force calculation to elegant pattern recognition. Once you have this new lens, this new way of seeing processes instead of just static states, you start to see its potential applications everywhere. It really encourages us to look back at other long-standing problems and ask ourselves, have we been making the same basic mistake all along? And that really brings us to the core thesis of this whole explainer. What we've been calling a paradox for so long might just be a dynamic process that we've been trying to cram into a static container. For centuries, we've been blaming the content for breaking the box, when maybe, just maybe, we should have been trying to build a better box. And that leaves us with one last, big, provocative question. This dynamic approach elegantly resolves the ancient liar paradox simply by reframing it. So, what other stubborn problems, what other so-called logical contradictions in science and philosophy, or even in our own lives, aren't actually contradictions at all, but are simply stable processes that we just haven't learned how to see yet?